In this example, we're going to look to solve for average velocity. In this case, it's a duck that's flying 22 meters north, 57 degrees east, and then east 28 degrees south for 11 meters. If the trip takes 4.4 seconds, we're going to try to find the average velocity. So step one again is to draw out a diagram that represents what our word problem has asked us. So if we're going to start off with our duck, let's say he's down here, and he's going to go 22 meters north, 57 degrees east. So that is approximately going to look something like this. So this is 22 meters. North 57 degrees east means that this angle here is our 57, whereas the angle that's probably going to be more useful to us is going to be the angle on the inside of the triangle once we're done. The bird then takes a turn for 11 meters, and it's going to go east 28 degrees south. So that might be something like this. So here's 11 meters. And again, that angle, east 28 degrees south, is this angle in here. So that's 28 degrees. We can then close up our triangle, knowing that this is going to be our dr. If we take a look just as a reminder, one of the equations we're most definitely going to need to use is our average velocity is going to be equal to our resultant distance change divided by our time. Okay, so to take a look at our triangle and to solve what's happening in here, we're going to make use of the cosine law. But before we can do that, we need to try to find some of the other angles in here. So by using a Z pattern, we can figure out that the angle inside here is also 57. And then by using our kind of related angle theories, so this one here is 57. This one here has to be 62. So that the net on the right side of that is equal to 90. In total, the angle we're dealing with in there, which we're going to solve for, is 57 plus 62 is equal to 119. So that's the angle opposite to dr, and that's really important because we need that for our cosine law, right? And when using cosine law, the angle you need has to be opposite to the side you're solving for. So let's take a look here now, and we'll make use of our cosine law. We're going to come back to this equation at the end. For now, we need to remember that when solving for a side like this, we're going to say that we're just looking for the distance. So this is a scalar quantity, and that's going to be equal to the square root of the first side plus the second side minus 2 times the first side times the second side times cos of the angle that's opposite to the side you're solving for. So we'll take this a couple steps at a time here. That gives us 484 plus 121 minus 484 cos 119. We keep solving one step at a time just to make sure we don't make any mistakes. It gives us 605 minus 234.6. Finally, that gives us the square root of 839.6. So the dr, the resultant distance here, is 22, or displacement, I guess, is 29 meters. We also need the angle that we're dealing with. So like we had said before, the angle that's going to be most useful to us is going to be this angle inside here, which is not the same as this entire angle here. So don't make that mistake because it's not quite at the horizontal. So to make use of that, we're going to make use of our, to solve for that rather, we're going to make use of our sine law. So remember that in a triangle, the sine of an angle divided by the opposite length to that angle is equal to the sine of a different angle divided by the opposite length to that angle. So that leaves us able to rearrange our sine law like this. And if you solve for that, you're going to get 19.4 degrees. And that's that inside angle that we're going to try to make use of. Now that inside angle, the one that's in blue here, is now 19.4 degrees. It in and of itself isn't super useful, but what we might make use of is the total angle coming off of the north side. So if we add that to 57, we're going to get 76.4 degrees, and that is our angle north, 74 degrees east. This, of course, is the same as saying our angle east, 13.6 degrees north. We can now go ahead and solve for our final answer, which is to look for the average velocity. So that's going to give us our displacement over time. Remember that our displacement was a vector value, and it was 29 meters east, 13.6 degrees north, and our time, 4.4 seconds. That leaves us with an average velocity of 6.6 meters per second, the direction east, 13.6 degrees north.